Okay, now this is session 6. So session 6 means it is a continuation of the session 5. So in this again we are solving some problems on the properties of steam. So this is continued. So continued means in the previous session also we have solved some problems. In this session also we are going to solve some more problems on the properties of steam. That is formation of steam under unit 1, right? So this is the problem. So this problem number 8, this problem, so we have solved in the previous session. So right. So once again we will look back what is the problem is given in the problem 8 and what he is going to ask in this problem, right? So a vessel contains 20 kg of steam at a pressure of 8 bar. Find the amount of heat which must be rejected so as to reduce the quality of steam in the vessel to be 70%. So quality of steam is nothing but it is the what type of steam it is. Quality of steam means what type of steam. So whether it may be a wet steam or dry steam or superheated steam. So that is also called as a quality of a steam, right? So he has given it is 70%. 70% of quality of steam means still the steam contains some amount of water molecules. So the steam is wet steam. ಸೊ ಅವನು ಏನ್ ಹೇಳ್ತಾ ಇದ್ದಾನೆ, ದ ಸ್ಟೀಮ್ ಏನಿದೆ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾನೆ. ಇದ್ರ ಪ್ರಕಾರ ನೋಡಿದ್ರೆ ವೆಟ್ ಸ್ಟೀಮ್ ಐತೆ ಅಂತ ಅರ್ಥ ಆಗತ್ತೆ ಇಲ್ಲಿ. ಸೊ ಅದಕ್ಕೆ ಅವನು ಏನ್ ಕೊಟ್ಟಿದ್ದಾನೆ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಅದನ್ನೇ ನಾನು ಬರ್ಕೋತಾ ಇದ್ದೀನಿ. ಸೊ ನಿಮ್ಗೆ ಕ್ಲಿಯರ್ ಆಗಿ ಹೇಳಿದೀನಿ ಏನಂತಂದ್ರೆ ನಾವು ಸ್ಟೀಮ್ ಟೇಬಲ್ ಅಲ್ಲಿ ಏನ್ ರೆಫರ್ ಮಾಡ್ತೀವೋ ಸ್ಟೀಮ್ ಟೇಬಲ್ ಅಲ್ಲಿ ಕೊಟ್ಟಂತಹ ಎಲ್ಲಾ ವ್ಯಾಲ್ಯೂಸ್ ಅದನ್ನ 1 kg ಆಫ್ ಮಾಸ್ಗೆ ನಾವು ಕಂಡು ಹಿಡಿದಂತಹದ್ದು ವ್ಯಾಲ್ಯೂಗಳು ಅವೆಲ್ಲ. So whatever the values tabulated in the steam table, all the values have been calculated for 1 kg of mass only. 1 kg of mass, 0 degree Celsius temperature and it is atmospheric pressure. So ಆ ಒಂದು ಕಂಡೀಷನ್ ಅಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಿ ಆ ಸ್ಟೀಮ್ ಟೇಬಲ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿರ್ತಾರೆ ವ್ಯಾಲ್ಯೂಸ್ ಅವನ್ನ. ಸೊ ರೈಟ್, ಬಟ್ ನಿಮ್ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ 1 kg ಅಂತ ಕೊಟ್ಟಿದ್ರೆ ಆಸ್ ಇಟ್ ಈಸ್ ಯು ಟೇಕ್ ದ ವ್ಯಾಲ್ಯೂಸ್ ಫ್ರಮ್ ದ ಸ್ಟೀಮ್ ಟೇಬಲ್, ದೆನ್ ಯು ಕ್ಯಾಲ್ಕುಲೇಟ್ ವಾಟ್ ಹ್ಯಾಸ್ ಬಿನ್ ಆಸ್ಕ್ಡ್ ಇನ್ ದ ಪ್ರಾಬ್ಲಮ್. Suppose if the mass is given something else other than 1 kg of mass, then you need to multiply the how much mass he has given for the calculated values. So right, so that is very important that you need to understand first. So I observe in the valuation most of the students they won't consider the mass, they won't see what is the mass given in the problem, how much mass is given in the problem, they won't see that at all. Say they will directly refer the steam table, they substitute the values and they will calculate the answers. So that is not correct. You first understand the problem clearly. So what he has given in the problem, how much mass he has given, and what is the type of the steam, whether it is a wet steam, dry saturated steam or superheated steam, you refer that, then you solve it neatly, right? So now I'll go for the solution. What is given here? The given is 8 bar. It is a pressure he has given 8 bar. So where he has given the 8 bar pressure? So 8 bar pressure is given here. So this is 8 bar pressure. So 8 bar pressure. So if I take 8 bar pressure and I have written 8 bar, M is given in the problem. M is how much? It is 20 kg. It is a M mass, right? So remember the steam table refers for 1 kg of mass. All the values given in the steam table is 1 kg. But in the problem given is 20 kg. It means whatever the values you are calculating, that should be multiplied by 20, right? So then next x2, this is the dryness fraction, it is given 70%. So it is 0.7. 70% means 0.7. Now from the steam tables at P1, so referring to the steam table, so if all of you having the steam table written by R. Kurmi, now open it. So go to the page number 11, I think. Open the page number 11. ಎಲ್ಲರೂ ಓಪನ್ ಮಾಡಿ ನೋಡ್ರಿ, ಅಂದ್ರೆ ಅರ್ಥ ಆಗುತ್ತೆ ನಿಮ್ಗೆ ಹೆಂಗ್ ನೋಡ್ಬೇಕು ಅನ್ನೋದು ಗೊತ್ತಾಗುತ್ತೆ. So open the page number 11. So in the first column there is a 8 bar pressure. So select the 8 bar pressure. So ಆ 8 bar pressure ಎಲ್ಲಿದೆಯೋ ಅದರ ಸ್ಟೇಟ್ ಆಗಿ ಹಾರಿಜೆಂಟಲ್ ಆಗಿ ಮೂವ್ ಮಾಡ್ತಾ ಹೋಗ್ಬೇಕು ಹಂಗೆ. If you move horizontally, so you will find the values, their value. So this is a Hg value. Hg means dry saturated steam value. It is given as 2767.5 kilojoules per kg. Means in the steam table it is given as 4. You can write it as 4 there. It is 4. 2767.4 kilojoules per kg. Then this is the specific volume. So Vg means it's the specific volume of dry saturated steam. If F comes, Gf comes, then it is wet steam. So it is not wet steam. He is finding it out. It is the dry saturated steam now. So coming to the specific volume here. So Vg column, go back again for Vg column. So in the steam table he has given 0.24026. 24026. If you want, you can take 26 also. It is not, it's correct. ನೀವು ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಬೇಕಾದಾಗ 0.24026 ತಗೊಂಡು ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಿದ್ರು ತಪ್ಪಿಲ್ಲ, ಮಾಡಬಹುದು. But for a shorter note I have taken, it is 0.24 only. So now therefore volume of vessel is equal to 20 into 0.24 is equal to 4.8 meter cube. This is what volume of the vessel. So this 0.24 is taken from the steam table. I told you already the values for only 1 kg of mass. It is only 1 kg of mass. Now this is multiplied for 20 because in the problem it is given 20 kg of mass. So multiply by 20. So you'll get 4.8 meter cube. It is the volume, right? Volume of the vessel. Now internal energy, go for initial internal energy, that is U1. So forget this negative sign. U1, this is internal energy. So that is H soup minus 100 P1 Vg1. So multiply H soup value as, it is not H soup, it is Hg. So I told you yesterday also, it is Hg. So 2767.5 minus 100 into 8 into 0.24. So this value will be 2575.5 kilojoules per kg. This is the internal energy, right? So the next one is now neglecting the volume of water in the wet steam. So neglect the volume of the water in the wet steam now. So when you neglect this, then what is the volume occupied by the steam? That is equivalent to the volume of the vessel. So volume of the vessel ಎಷ್ಟಿರುತ್ತೋ ಅಷ್ಟೇ ವಾಲ್ಯೂಮ್ದು ನೀವು ಸ್ಟೀಮ್ ಆಕ್ಯುಪೈ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಆಕ್ಯುಪೈ ಮಾಡೋಕ್ಕಾಗಂಗಿಲ್ಲ. ಅದಕ್ಕೆ volume of the steam is occupied by the steam is equal to volume of vessel I have taken here, right? So this 20 into 0.7 into Vg2 is equal to 4.8 because volume of vessel already we have calculated, that is 4.8 now. So you need to find out the volume of the steam now. So this is 20 into 0.7 because it is a wet steam. Volume occupied by the steam. What steam is going to occupy the volume? Yav steam vessel volume anna occupy maduttandre, it is wet steam because in the problem he has given the quality of the steam is 70%. So adike 20 is a mass into 0.7 is wet steam. So it is into Vg. You know already volume of wet steam. Volume of wet steam. So is equal to, what is the formula? XVG. XVG. Idu gotta nim formula already we have derived this. This one you have seen, it is XVG. X is dryness fraction. Vg is volume, specific volume of the dry saturated steam. But 20 is there because this formula is for 1 kg. So this in the problem given as 20 kg mass. So 20 into 0.7 into Vg is equal to 4.8. Therefore, so Vg, to keep it on the left hand side only, 20 into 0.07 will come at the bottom side. So after calculating, the answer will be 0.343 meter cube per kg. So this was the answer, right? So now this is the volume of the wet steam. This is the volume of the wet steam. So from the steam table, again by taking this value, this specific volume, from this specific volume we have noted down these values. Ivella values ellinda ಕಂಡಿಡಿದ್ವಿ specific volume ಇಂದ. ಇಲ್ಲಿವರೆಗೂ ಹೇಳಿದ್ದೆ last class ಅಲ್ಲಿ. But ಇದನ್ನ ಹೆಂಗ್ ತಗೋಬೇಕು ಅನ್ನೋದನ್ನ ನಿಮಗೆ ಸ್ವಲ್ಪ ಕನ್ಫ್ಯೂಷನ್ ಇತ್ತು. That one I have written it in the red color here. So ಅದನ್ನೇ red color ಅಲ್ಲಿ ನಾನು ಬರೆದಿದ್ದೀನಿ ಈಗ. So now you can refer carefully. So see here Vg. So now you go to the steam table again. Steam table, you refer the steam table again. The steam table means, in the steam table again open page number 11. Page number 11 anna ತಗೊಳ್ರಿ ನೀವು. If you take the page number 11, so when you go to the page number 11, there Vg2 is equal to 0.343 meter cube per kg. So this value, this volume, where it is now? So this volume is, so 0.343 meter cube per kg volume, where it lies. ಸೊ ಎಲ್ಲಿ ಬರುತ್ತೆ ಆ ವಾಲ್ಯೂಮ್ ಅನ್ನೋದನ್ನ ಸ್ಟೀಮ್ ಟೇಬಲ್ ಅಲ್ಲಿ ನೋಡ್ಬೇಕು ನೀವು. ಸೊ ಅದು ಎಲ್ಲಿ ಬರುತ್ತೆ ನೋಡ್ರಿ, ವಿ ಜಿ ವಾಲ್ಯೂಮ್. ಸೊ ಕಮಿಂಗ್ ಟು ದ ಪೇಜ್ ನಂಬರ್ 11, 0.343 ಎಲ್ಲಿ ಬರುತ್ತೆ ನೋಡ್ರಿ. ಈಗ 0.343 ಎಲ್ಲಿ ಬರುತ್ತಪ್ಪ ಅಂತಂದ್ರೆ, ಸೊ 5.4 ಅಂಡ್ 5.6 ಮಧ್ಯದಲ್ಲಿ ಬರುತ್ತೆ. 5.4, 5.6, 5.4 ವಾಲ್ಯೂಮ್ ಎಷ್ಟಿದೆ? 0.34844 ಇದೆ. ಸೊ ಅದನ್ನೇ ನಾ ಇಲ್ಲಿ ಬರ್ಕೊಂಡಿದ್ದೀನಿ ಈಗ. Right, so I have written the same thing there. So it means, see now, this value, this is specific volume of dry steam with respect to the pressure 5.4 pressure ಗೆ ಸಂಬಂಧಪಟ್ಟಿದ್ದದು. ಸೊ ಅದೇ ರೀತಿ ನೆಕ್ಸ್ಟ್ 5.6 ಗೆ ಎಷ್ಟಿದೆ? 0.33669 ಇದೆ. ಸೊ ಅದು ಎರಡರದ್ದು ಎವರೇಜ್ ತಗೋಬೇಕು. ಯಾಕಂದ್ರೆ ನಮ್ದು ಸ್ಪೆಸಿಫಿಕ್ ವಾಲ್ಯೂಮ್ ಇರೋದು ಎಷ್ಟಿದೆ? 0.343 ಇದೆ. 0.343 ಸ್ಟೀಮ್ ಟೇಬಲ್ ಅಲ್ಲಿ ಇಲ್ಲ, ಬರೋದಿಲ್ಲ. ಸೊ ಅದಕ್ಕೆ ನಾವೇನ್ ಮಾಡ್ಬೇಕಂದ್ರೆ 0.343 ಎರಡು ಸ್ಪೆಸಿಫಿಕ್ ವಾಲ್ಯೂಮ್ ಮಧ್ಯೆ ಬರ್ತಾ ಇದೆ ಈಗ ನಮ್ಗೆ. ಸೊ ಅದಕ್ಕೆ ನಾನು ಏನ್ ಮಾಡಿದ್ದೀನಿ ಅಂದ್ರೆ, ಐ ಹಾವ್ ಟೇಕನ್ ಇಟ್ ಆಸ್ ಎವರೇಜ್ ಇಯರ್. 0.34844 ಪ್ಲಸ್ 0.33669 ಡಿವೈಡೆಡ್ ಬೈ 2 ಮಾಡೀನಿ. ಅವಾಗ ಎಷ್ಟು ಬರುತ್ತೆ? 0.342565. So this is approximately 0.343. So ಇದು ಅಪ್ರಾಕ್ಸಿಮೇಟ್ ಆಗಿ ಎಷ್ಟಾಗುತ್ತೆ? 0.343 ಬರುತ್ತೆ. ಸೊ ದಿಸ್ ಈಸ್ ದಿ ವಾಲ್ಯೂಮ್. ಸೊ ಅವಾಗ ಪ್ರೆಷರ್ ಕಂಡುಹಿಡಿಬೇಕು ನಾವು. ಅಂದ್ರೆ ಪ್ರೆಷರ್ ಕೂಡ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಎವರೇಜ್ ಆಗುತ್ತೆ ಅವಾಗ. ಸೊ ವಾಲ್ಯೂಮ್ ಅನ್ನ ಎವರೇಜ್ ತಗೋತಾ ಇರ್ತೀವಿ ಅಂದ್ಮೇಲೆ ಪ್ರೆಷರ್ ನೀವೇನ್ ತಗೋಬೇಕು? ಅವಾಗ ಎವರೇಜ್ ತಗೋಬೇಕು. ಎವರೇಜ್ ಅಂದ್ರೆ 5.4. ಇದೇನು ವಾಲ್ಯೂಮ್ ಇದೆ ಅಲ್ಲ, ದಿಸ್ ವಾಲ್ಯೂಮ್ ಇಸ್ ರಿಲೇಟೆಡ್ ಟು 5.4 pressure and this volume is related to 5.6 pressure. ಸೊ ಇಲ್ಲಿ ಎರಡು ವಾಲ್ಯೂಮ್ ಎವರೇಜ್ ತಗೋತಾ ಇದ್ದೀವಿ. ಸೊ ಇಲ್ಲಿ ಪ್ರೆಷರ್ ಕೂಡ ಯು ಹ್ಯಾವ್ ಟು ಟೇಕ್ ಇಟ್ ಎವರೇಜ್. ಸೊ 5.4 plus 5.6 divided by 2, so that will be 5.5 bar pressure. So that the same thing I have written here. It is 5.5 bar pressure. So how to refer the steam table? Referring the steam table, if the volume given is not find exact value in the steam table, ಏನು ಆ ವಾಲ್ಯೂಮ್ ಎಕ್ಸಾಕ್ಟ್ ವ್ಯಾಲ್ಯೂ ಸ್ಟೀಮ್ ಟೇಬಲ್ ಅಲ್ಲಿ ನಮ್ಗೆ ಸಿಗದೆ ಇದ್ರೆ ನೀವೇನ್ ಮಾಡ್ಬೇಕು? ಅವಾಗ ಎವರೇಜ್ ಅನ್ನ ತಗೋಬೇಕು. ಸೊ ಎವರೇಜ್ ಅನ್ನ ತಗೊಂಡ್ಮೇಲೆ ನೀವು ವಾಲ್ಯೂಮ್ ಅನ್ನ ಅಷ್ಟೇ ಎವರೇಜ್ ಅಲ್ಲ, ಸೊ ಅಲ್ಲಿ ಬರ್ತಕ್ಕಂತ ಪ್ರೆಷರ್ ಆಗಿರ್ಬೋದು ಅಥವಾ ಎಂಥಾಲ್ಪಿ ಆಗಿರ್ಬೋದು, ಏನ್ ವಾಟ್ ಎವರ್ ಇಟ್ ಮೇ ಬಿ, ದ ಎಂಥಾಲ್ಪಿ ಆಫ್ ವಾಟರ್, ಎಂಥಾಲ್ಪಿ ಆಫ್ ವೆಟ್ ಸ್ಟೀಮ್, ಎಲ್ಲನೂ ಕೂಡ ಯು ಹ್ಯಾವ್ ಟು ಟೇಕ್ ಎವರೇಜ್. ಸೊ ಆಲ್ ಥಿಂಗ್ಸ್ ಯು ಹ್ಯಾವ್ ಟು ಟೇಕ್ ಎವರೇಜ್. ಸೊ ನೌ ದ ಪ್ರೆಷರ್ ಈಸ್ 5.5 bar. Similarly, HF is there. So this HF also I have taken average. So HF average means first you have to take 5.4 along the 5.4 you move horizontally. So when you come there, HFG value is 2000, HF value is 652.8 value. This is the value. This value is related to 5.4 pressure and this value is related to 5.6 pressure because you have to take average. So that divided by 2, so that will give you the 655.8 kilojoules per kg. This is actual HF. This HF with respect to what specific volume? It is with respect to 0.343 specific volume. So this is average. Similarly, you have to take average for HFG. HFG gu kuda ee riti average tagobeku. So HFG, this is HF2 is 655.8. HFG2 is this much value. E value hang bantandre you have to take average. Average means HFG value with respect to 5.4 pressure. 5.4 pressure ge ಎಷ್ಟು ನೋಡ್ರಿ. 5.4 pressure ge the value is 2098.1 ಇದೆ. 5.6 pressure ge the value is 2093.7 ಇದೆ. ಸೊ ಅವು ಎರಡನ್ನು ಆಡ್ ಮಾಡಿ divided by 2 ಮಾಡಿದ್ರೆ you will get, so this HF2 value as 2095.9 E value ಬರುತ್ತೆ. So that also have to take it average. Then therefore the final internal energy U2 is equal to HF2 plus X2 HFG2 minus 100 P2 X2 VG2. So initially the steam was dry saturated steam. So after expansion that becomes wet steam, means with 70% of the dryness fraction. So the substitute the values here. So HF2 is 655.8 plus 0.7 into 2095.9 minus 100. P2 is 5.5, X2 is 0.7 into the volume is 0.343. Then you will get the answer as 1991 kilojoules per kg. Right? This is the internal energy, final internal energy. So he is asking to find out the heat rejected. So heat rejected means then you have to subtract these values. ಈ values ಅನ್ನ subtract ಮಾಡಬೇಕು. So 2575.5 minus, so this you can minus how much? Minus 1991. So that will be 584.5 kilojoules per kg. Right? So this is the heat rejected. Therefore, heat rejected by 20 kg of steam. This is for how much? For 1 kg, and multiply it by 20. So it will be 11,690 kilojoules per kg. This is the heat rejected by 20 kg of steam. Right? So this is the yesterday session problem. So how to see the steam table whenever the given specific volume is not present in the steam table. Exact value steam table ಅಲ್ಲಿ ಸಿಗದೇ ಇದ್ರೆ ನಾವು ಯಾವ ರೀತಿಯಾಗಿ ಅದನ್ನ ಸ್ಟೀಮ್ ಟೇಬಲ್ ಅಲ್ಲಿ ನೋಡಬೇಕು. ವಿ ಹ್ಯಾವ್ ಟು ಫೈಂಡ್ ಇಟ್ ಔಟ್ ದಿ ಅವರೇಜ್ ಆಫ್ ಇಟ್. ಅವರೇಜ್ ಅನ್ನ ತಗೊಂಡ್ಬಿಟ್ಟು ನೋಡಬೇಕು. ರೈಟ್? ಸೊ ವಿಲ್ ಮೂವ್ ಆನ್ ಟು ದಿ ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್. ಸೊ ದಿಸ್ ಇಸ್ ದ ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್. ಸೊ ಪ್ರಾಬ್ಲಮ್ ನಂಬರ್ 8. ಎ ಸ್ಯಾಂಪಲ್ ಆಫ್ 1 kg ಆಫ್ ಸ್ಟೀಮ್. ಸೊ 1 kg ಅಂತ ಕೊಟ್ರೆ ಇಟ್ಸ್ ವೆರಿ ಸಿಂಪಲ್. ಸೊ ಅವಾಗ ನಾವು ಒಂದ್ ಸ್ವಲ್ಪ ಆರಾಮ್ ಉಸಿರು ಬಿಡಬಹುದು. ಯಾಕಂದ್ರೆ ಡೈರೆಕ್ಟ್ಲಿ ವಾಟ್ ಎವರ್ ದ ವ್ಯಾಲ್ಯೂಸ್ ಐ ವಿಲ್ see it from the steam table, directly I can calculate. No need to multiply and all. Right? So that is a sample of 1 kg of steam at a pressure of 15 bar exists in the following two conditions. First one is wet steam with dryness fraction 0.8, superheated steam with a temperature of 215 degrees Celsius. Determine the following properties in each case. ಅಂದ್ರೆ ಎರಡು ಕೇಸ್ ಕೊಟ್ಟನು. ಏನ್ ಹೇಳ್ತಾ ಇದ್ದಾನೆ? 1 kg of steam ಇದೆ, at a pressure, ಎಷ್ಟು ಪ್ರೆಷರ್ ಇದೆ? 15 ಬಾರ್ ಪ್ರೆಷರ್ ಗೆ 1 kg ಆಫ್ ಸ್ಟೀಮ್ ಐತಿ ಅಂತ ಹೇಳ್ತಾನೆ. ಸೊ ಫಾಲೋವಿಂಗ್ ಪ್ರಾಪರ್ಟೀಸ್ ಮೀನ್ಸ್ ದೀಸ್ ಆಲ್ ಪ್ರಾಪರ್ಟೀಸ್, ಇವೆಲ್ಲ ಪ್ರಾಪರ್ಟೀಸ್ ಕಂಡು ಹಿಡಿದ್ರಿ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾನೆ. ಯಾವಾಗ? ಎರಡು ಕೇಸ್ ಅಲ್ಲಿ. ಫಸ್ಟ್ ಕೇಸ್ ಏನು? when the steam is wet steam means the dryness fraction is 0.8. Superheated steam with a temperature of 215 degrees Celsius. ಒಂದು ವೆಟ್ ಸ್ಟೀಮ್ ಇದೆ, ಒಂದು ಸೂಪರ್ಹೀಟೆಡ್ ಸ್ಟೀಮ್ ಇದೆ. ಈ ಎರಡೂ ಕೇಸಲ್ಲಿ you find out the enthalpy, volume, entropy, then external work, then internal energy. So all these 5 properties you need to find out in 2 cases. ಎರಡು ಕೇಸಲ್ಲಿ ವೆಟ್ ಸ್ಟೀಮ್ ಇದ್ದಾಗ ಅದರ ಎಂಥಾಲ್ಪಿ ಎಷ್ಟಿರುತ್ತೆ, ವಾಲ್ಯೂಮ್ ಎಷ್ಟಿರುತ್ತೆ, ಎಂಟ್ರೋಪಿ, ಎಕ್ಸ್ಟರ್ನಲ್ ವರ್ಕ್, ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ. ಸಿಮಿಲರ್ಲಿ ಸೂಪರ್ಹೀಟೆಡ್ ಸ್ಟೀಮ್ ಇದ್ದಾಗ ಏನಿರುತ್ತೆ, all the properties you need to calculate now. So now solution. What is given? Given is 15 bar pressure. And also superheated steam temperature he has given, that is 215 degrees Celsius. And also Cp is given, that's the specific heat of superheated steam is 2.3 kilojoules per kgK. So that is given here at the end. Take the specific heat of superheated steam is 2.3 kilojoules per kgK. Neglect the volume of water. It is given in the problem. So what is given? First pressure 15 bar is given. Then a super heated temperature, that is also given as 215 degrees Celsius. Specific heat of superheated steam is given as 2.3 kilojoules per kgK. Right? Then you can go for the from the steam tables, refer the steam table. Then for go for the 15 bar. So this is, I think this is wrong. This is not 8 bar. This is 15 bar. Take it 15 bar. So refer the steam table for 15 bar. Go to the 15 bar table. So go to the 15 bar table. Open the steam table book. RS Kurmi, page number 12. 15 bar pressure. Go to the 15 bar pressure. Move along horizontally. So when you move horizontally, the value given is 8. HF value is 844.6. So it is 844.6 it is. In the steam table, it is given as 844.6 value. You have to take same thing, same value. So I think I have this one, I have copied it from the book, some book. So I have kept the same value. You don't round it off. Adanna round off ಮಾಡ್ಕೋಬೇಡ್ರಿ. So steam table ಅಲ್ಲಿ ಏನು ವ್ಯಾಲ್ಯೂ ಇರುತ್ತೋ ಅದೇ ವ್ಯಾಲ್ಯೂ ಅನ್ನು ತಗೋಬೇಕಿಲ್ಲಿ. So then HFG value in the steam table given as 1945, not 47, it is 45.3 it is. You have to take that same value only. 1045.3 kilojoules per kg. Same value you have to take it. Then saturation temperature is given as 198.3 degrees Celsius. It is given in the steam table. So very next column, 15 bar pressure magla idri. Magla 198.3 kodan. That itself is saturation temperature, right? Then you take the SF value. SF value is 2.314 is there in the steam table. Take 314 only. The next one is 4.154 you have to take. That is SFG. So it is 127 in the steam table. You have to take 127 only. It is 127 only, right? So then VG is 0.1317. So it is, you can round it off, it is okay. This is correct. So it is 0.1317. So for the first case, one case it is wet steam with dryness fraction is how much? With the dryness fraction of 0.8 anta ಹೇಳ್ತಾ. So if you take 0.8, so then find out enthalpy. Enthalpy is H wet is equal to HF plus XHFG is equal to, substitute all the values. Illen correction madini aa values anna you can substitute it here. So then after substituting you will get the answer as, so it is 2402.6 kilojoules per kg. Similarly, what is the specific volume? Specific volume, that is Vs is equal to XVG. So that is 0.8 into the specific volume, that is 0.1317. So that will be 0.10536 meter cube per kg. So entropy, because given is wet steam, so S is equal to SF. This is entropy of water plus it is entropy of wet steam multiplied with dryness fraction. So it is 2.315 plus 0.8 into 4.154. So the answer will be 5.638 kilojoules per kg. This is the entropy. So similarly, external work, W is equal to, so this is 100 pxvg, 100 pxvg. So that is 100 into P is 15 into dryness fraction is 0.8 into, say this is 0.1317. This is specific volume of wet steam. So that answer will be 158.04 kilojoules per kg. This is the work done, that is external work. Now internal energy, you know already, this is a heat, there is nothing but enthalpy minus work, W. Why I call this as Y enthalpy? Because the heat supplied at constant pressure. So if the heat supplied at constant pressure means it is enthalpy. So in the basic thermal engineering, this is Q, this was Q minus W. But now we are calling this as H means enthalpy. Why? Because the heat is supplied at constant pressure. So substitute all the values. 2402.6 minus 158.04. So that is equal to, so 2244.56 kilojoules per kg. Then second case, go for second case. For superheated steam with T soup is 250 degrees Celsius. It is given in the problem. So write the formula for enthalpy. So H soup is equal to HF plus HFG. So this is for enthalpy of dry steam. This is the extra heat you are going to add, that is Cp T soup minus T saturation. So substitute all the values here, you know all the values. So after substituting, then you will get 2830.41 kilojoules per kg. Then so what is the specific volume? Vs is XVG. So 0.8, 0.1317. In the earlier case, this was multiplied by dryness fraction, that is 0.8. But in this case, you are not multiplying because you are calculating for the superheated steam. So 0.8 into 0.1317. So that is equal to 0.10536 meter cube per kg. Then go for entropy. Entropy is S is equal to SF plus XSFG. So that is equal to 2.313 plus 0.8 into again 4.154, that is equal to 5.638 kilojoules per kgk. So the next again external work done, similarly W 100 P into Vg. So again multiply this. So this is 0.8, 0.1317. So you don't take 0.8 here because it is superheated steam. So you don't take this because it is only PVG 15 into 0.1317. Only multiply 100 into 15 into Vg. X will not come here because we are calculating for superheated steam. So then this value changes now. Multiply only these three values, you will get some answer. So we put that answer. This answer is not correct here. Then internal energy, U is equal to H minus W. Substitute these two values. Again, you will get the answer here. So this is what in the two cases, when the steam is wet and when the steam is superheated steam. Then go for problem number 7. This is the last problem. So 1 kg of steam at 8 bars and 0.8 dry receives 300 kilojoule of heat at constant pressure, right? So then determine the enthalpy, condition and density of steam at the end of constant pressure heat supply. So here also 1 kg given. Okay, no problem. Then whatever the values given in the steam table, the same values you note it down, then you can calculate it. So 8 bar is given. So 0.8 dry. 0.8 dry means it is understood it is wet steam, right? So write the given data. Given is P 8 bar, X is 0.8. Heat received is how much here? 3 kilojoules per kg. Then from the steam table, refer again steam table for P is 8 bar. So go to again the steam table. If you have RS Kurmi book, open RS Kurmi book, open the page number 11. So again 8 bar, refer 8 bar pressure, move horizontally. So you will find HF as 720.9 kilojoules per kg. Then HFG is equal to so 2046.5 kilojoules per kg, right? So then Hg is 2767.4 kilojoules per kg. So then saturation temperature is 170.4 degrees Celsius. Then Vg is 0.24026 meter cube per kg, right? These are all the values from the steam table. Then find out enthalpy of wet steam. So how to find out enthalpy? H is equal to HF plus XHFG. Substitute all the values. 720.9 plus 0.8 into 2046.5. So that is equal to 2358.1 kilojoules per kg. So he has given in the problem the heat added at constant pressure is 300 kilojoules per kg. This heat you have to add it with this now. Therefore, enthalpy after heat addition. After heat addition, how much heat will be there? So 2358.1 plus 300. So that is equal to 2658.1 kilojoules per kg. So therefore, the enthalpy of steam after heat addition is less than the dry saturated steam at the same pressure. Hence, the steam is wet. So right, it means first ist heat ಕಂಡಿಡಿದ್ರಿ, ಇದು ಕಂಡಿಡಿದ ಮೇಲೆ 300 ಎಕ್ಸ್ಟ್ರಾನ ಆಡ್ ಮಾಡ್ತೀನಿ. ಆಡ್ ಮಾಡಿದಾಗ ದ ಸ್ಟೀಮ್ ಡ್ರೈ ಆಗುತ್ತೋ ವೆಟ್ ಆಗುತ್ತೋ ಹೇಳ್ರಿ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾನೆ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ. ಸೊ ಕಂಡಿಡಿದಿದ್ದಕ್ಕೆ 300 ಆಡ್ ಮಾಡಿದ್ಮೇಲೆ ಎಷ್ಟು ಬಂತು? 2658.1 kilojoules per kg ಬಂತು. ಈ ಬಂದಂತ ಹೀಟ್ ಸೊ ನೀವು ಪ್ರೀವಿಯಸ್ ಸ್ಲೈಡ್ ಅಲ್ಲಿ ಕಂಡಿಡಿದಿರಲ್ಲ, ಇಲ್ಲಿ ಕೆಳಗಡೆ. ಸೊ ದಿಸ್ ಇಸ್ ಯು ಹ್ಯಾವ್ ರಿಟನ್ Hg value here, right? So this value, Hg value. So this Hg value means this is related to the dry saturated steam. Dry saturated steam ಯಾವಾಗ ಆಗುತ್ತಾ? 8 bar pressure ಇದ್ದಾಗ, when it is 2767.4 ಬಂದಾಗ ಮಾತ್ರ ಅದು ಡ್ರೈ saturated steam ಆಗುತ್ತೆ. ಬಟ್ ನೀವು ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ತಾ ಇದ್ದೀರಿ, ಅದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಿ ಆದ್ಮೇಲೆ 300 ಆಡ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ ಅಂತಾನೆ, ಇಲ್ಲಿ ಬಂದಂತ ವ್ಯಾಲ್ಯೂ ಏನೈತಲ್ಲ, ದಿಸ್ ವ್ಯಾಲ್ಯೂ ಆ ಡ್ರೈ ಸ್ಯಾಚುರೇಟೆಡ್ ಸ್ಟೀಮ್ ಅದೇನು ಕಂಡಿದ್ದೀವಿ ಆ ವ್ಯಾಲ್ಯೂಕ್ಕಿಂತನೂ ಕಡಿಮೆ ಇದೆ ಇದು. ಸೊ ಕಡಿಮೆ ಇದ್ದ ಸಂಬಂಧ ಏನಾಗುತ್ತೆ, ಅಗೇನ್ ಆಫ್ಟರ್ ಎಡಿಷನ್ ಆಫ್ 300 kilojoules of heat ಆಲ್ಸೋ ದ ಸ್ಟೀಮ್ ಈಸ್ ವೆಟ್ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾನೆ. ದಿಸ್ ಇಸ್ ವೆಟ್. ದೆನ್ he is asking you to find out density of wet steam. Density of wet steam is 1 by V wet is equal to 1 by X Vg. So this V wet ಅಂದ್ರೆ specific volume of wet steam ಹೆಂಗ್ ಕಂಡಿಡ್ತೀರಿ? So the specific volume of dry saturated steam is multiplied with dryness fraction. ಸೊ ದೀಸ್ ಟು ಈಕ್ವಲ್ ಆಗ್ಬೇಕು ಅವಾಗ. ವೆಟ್ ಸ್ಟೀಮ್ ಅಂದ್ರೆ ಸೇಮ್ ಎರಡು ಈಕ್ವಲ್ ಆಗುತ್ತೆ ಅವಾಗ. ಸೊ ದೆನ್ ಫೈಂಡ್ ಔಟ್ 1/0.8 into 0.24. So this is equal to 5.028 kg per meter cube. This is the density of the steam. So thank you. This is the end of the